Hi, this is a rundown of homework 2. So I wanted to give a brief overview of how you do homework 2. In the inputs, I've created this section here for all of the inputs, so you can see going down using the notation we used in class. We have demand, which is 5,000 units. We have 365 days per year. We have the standard deviation of demand, which is 7 cases, the case value, which is $200, the annual inventory holding cost, which is 28%, the ordering cost A, which is $100 per order, in transit inventory, which is W, which is 18%. We have the transit time. So I've got 2 sections here. One, transit time for A, which is transit time for air, which is 2 days, and for road it is 5 days. And then we have the transportation costs is $1.50 per hundredweight for air, and $80 per hundredweight. And then we have 50 pounds per unit. So I've actually converted the weight directly into hundredweight. So it's 50 pounds is half CWT, which is half of a hundredweight. So that's my input. I've also, I should format this as well. I formatted all of the calculations. So here is the average demand per day. So the average demand is the annual demand divided by the days per year. These are in blue. My PNS is the cost of an underage, which is the B, $200 over the cost of an underage plus the cost of the overage, which is inventory holding cost, which is V times H, and that works out to 78%. I have calculated my standard deviation of lead time, which is the average of air times the mean of the demand, the variance of the demand, or the sigma d squared, plus the mean of the demand squared times the sigma a squared. So that's the standard deviation of lead time demand using air, and likewise for the road as well. Now, on to the first question. What is the EOQ for baseball card emporium in cases and in pounds? So a very simple calculation. I have 2 times the AD. We have 2AD, which is twice the order cost and the annual demand over the value times H. I've rounded it up, but you can keep it as it is. Rounding it up because we are talking about whole cases, so that works out to 134. When you look at the EOQ, it's EOQ times the weight times 100. That gives it to you in pounds, because I multiplied by the weight, which is 100 weight times 100 pounds. So that's why you give you. I've used that. I've used that expression to give me the cases, the economic order quantity in cases for pounds. To calculate the ordering cost, it's very simple. Again, it is the demand over the EOQ times the ordering cost, as you can see here, and the inventory carrying cost, similarly, it's half of Q over 2 times VH. So instead of taking Q over 2, I just multiply by half. And so the total cost works out to be 7,480. So in that case, we've answered questions 1 and questions 2, which is including only ordering costs and inventory carrying costs. What is the total cost of the EOQ? So this, of course, is independent of any transportation costs, and that's where question 3 goes in, where now we have first calculate the EOQ for assuming that demand is uncertain. So we now have a certain number of excess. So we have about 11 units excess for air and 13 units excess for road, and we have about 4 units short for air and 3 units short for road in each cycle. So what we have to do is take that into account to calculate the EOQ, which now, let me slide this up. You can see it's the new formula. So square root, and again I've rounded it up to the nearest 0 decimal place. So 2 times the demand in brackets the ordering cost plus B, which is the stock out cost, times the expected shortage by air over V times H. And so we do the same thing for road, and the economic order cost for air and road is given by these two. Similarly for of course, I've named these cells, so here you can see this is EOQ air and this is EOQ road. So when I calculate, you can see the highlighting of the respective cells for calculating the costs. So that's inventory carrying cost, just like same time. Excess cost is the excess air cost, which again I've named it E air, E underscore air, and the underscore is only to indicate that that's a subscript, so E subscript air, and this is E subscript road. All right. The shortage cost is how many cycles I have, so the D over Q, the EOQ by air, times my shortage cost for each item short multiplied by the number of items I have short, and that is my shortage cost by road. And you can see that the sum of these is my total cost. Okay, so that answers question 3. So these is question 3A and C for the EOQs, and then we have question B and D for the EOQ of air and the total cost for air and the total cost for road. Finally, we have, not finally, but we have question 4. And question 4 is talking about what is the critical ratio, which I've already pointed out over here. So that's question 4, the critical ratio. And then we have the pipeline and safety stock cost for the air carrier. So to calculate the pipeline stock cost, we already have these quantities calculated out, so I'm not going to bother with that already. So we have the average lead time demand by air times V times W. So we have the average lead time demand by air, which I've named mu x air, and it is simply the average lead time by air multiplied by the average demand. So that's calculated here, and similarly we have mu x mu sub x road, which is the average lead time demand for road multiplied by the W and the V, and we've calculated the average lead time demand by road simply by mu road, which is 5 times the average lead time by the average demand, which is the same as we use for air. So that is the pipeline stock cost. The safety stock, we have the sigma x, which I've already shown you how to calculate, the standard deviation of lead time demand for air and for road, multiplied by V times H multiplied by K. So remember that you have K times sigma x. So this is our K, norm dot S dot inverse, which is a standard normal inverse function of the PNS, which is 78%, and that gives us the calculation for safety stock cost. Similarly, we have the sigma x road times K times VH, which is the safety stock cost for the road. And then we have the transportation cost, which is just simply how much the total demand multiply by the weight of each case. Remember, that's already converted to 100 multiplied by the transportation cost, in this case by air, and here we have it by road. Okay, so again it's demand times the weight times the transportation costs per hundredweight. And of course, we total that up, and that comes out to be our total cost. And that total cost is question 5. And over here I have put in a graph so you can see what the trade-offs are. And these trade-offs are going to be useful when you actually look at the extra credit. So I'm not going to give anything away at this point. I want you to think about it, and if you have any questions, you can come and talk to me, and we can talk about the extra credit. But basically, this graph is to help you, and you can see clearly the trade-offs. For example, in transportation costs, much smaller for truck, for road versus air, and higher for safety stock versus for road versus air, and also higher for pipeline stock in road versus air. So clearly there are some trade-offs going on over there. Another trade-off that you can see is shortage costs. Clearly, very large percentage of your total costs. So your total costs are around 25 to 27,000. Your shortage cost is almost a third of that. Is more than a third of that. So 35 to 40% of that is shortage cost, which is based upon only a few unit shots per cycle. So clearly there's some trade-offs at play over there, and you might want to take a look at some of those trade-offs and figure out how you're going to answer questions 1, 2, and 3. All right, so that's it for the rundown with homework 2. Hopefully this helped you, and you might be able to understand the inventory management module a little bit better. Thank you.